choosing a sample size is very interesting when it comes to stats, because if we have a desired margin of error, so far we've taken a sample and then we've decided what a 90% confidence interval is, and then with some margin of error, and we can actually work backwards and say, you know what, I want to have a sample, a margin of error only so big, so make it really tight, right? And we can work backwards and we can calculate how large the sample would need to be for us to get that kind of answer. So it's very interesting, actually. So typically we go 25 to 30 people in our sample, but if we really wanted to go backwards and kind of be in control of our destiny per se, we can actually work backwards and decide how many we actually would have to get. And being true to AP stats and traditional stats, there's plenty of formulas for that kind of stuff. So here's what our formula is. So we start by assuming that it's a normal distribution. That's what this means. So we're going to assume that it is. With that information, this is our formula. So we have a C star, which we saw before, and that's, we get that value based upon what kind of confidence we want, 90, 95, 99, etc. M is our margin of error that we want to have. So if we want it very small, that's where we would put it. And then we have this. So this is the probability of something happening, and this is the probability of it not happening. But what is P star? Well, we know what P hat is. That's the sample proportion. But P star is a value that you put in there that you can either guess or have previous information about the population you're talking about. So P star would be to say, I read an article and it said that 70% of all people drive to school, they're in high school, or that are seniors. We would put in 0.7 because we're taking that from a study. So there's some information out there to give us an educated guess. But if I don't have any information, if it's totally blind, then I would choose the best probability that there is when it comes to something not being known to you, and that is 0.5. So it's a decision to make about, do you have previous study information to use as a probability, or do you not? And if you don't, use 0.5 because it's the fairest. So here's our example. What sample size would you need in order to achieve a margin of error no more than 0.01? That's pretty tight. That's pretty impressive. For a 90% confidence interval for the population proportion of arthritis parents who suffer from adverse symptoms. We could use 0.5 as a guessed p-hat. However, since the drug has been approved for sale over the counter, we can safely assume that no more than 10% of patients should suffer adverse effects, which is a previous information, again, an educated guess. We have some information there to help us be more focused, so it's better than using just 0.5, so we're going to use a value that they give us, which is 0.1, so 10%. So if we go to our formula, we have a Z star, which we said for 90% confidence was 1.645. These come from tables in the back of the book. Also tables given to you for the AP test. We have the Z star then put right here. We have our 10%, which is written here. That's our P star. The probability of it occurring, the probability of it not occurring. And don't forget this key thing here. It is squared. And this calculation gives us this number. So we would need to get this margin of error with that confidence. We would need at least 2,434, which we should round to 2,435, because if we're rounding down, we'll be one less than we need to be hitting our criteria that we've talked about. So we want to go up. Always make the sample size bigger in this case. So 2,435 patients needed to hit that criteria.